In this video, we will practice how to balance chemical equations. A chemical equation is a sentence which gives us some information about a reaction. It has three main parts: the reactants, or the chemicals that we start with, an arrow, which means to produce or to form, and then the products, which are the chemicals that are formed from the react. So it reads, for example, sodium and chlorine forms sodium chloride. Apart from telling us what is reacting and what is being formed, a chemical equation can give us further information, such as the conditions under which the reaction takes place, or the ratio of reactants and products. In order to get these quantities, however, we must observe the law of conservation of matter, which states that matter cannot be created nor destroyed. All the atoms that exist at the beginning of a reaction must be present at the end of the reaction. During a chemical reaction, atoms are rearranged, but even though the structure may be different, the number of atoms must still be the same. So, to balance a chemical equation, we must ensure that the number of atoms of each element is the same on either side of the arrow. For the equation that we just saw, sodium plus chlorine forms sodium chloride. Let's look at the number of each atom that is present. We have one sodium atom on the reactant side, two chlorine atoms on the reactant side, and that's on the left-hand side of the arrow. And on the product side, which is on the right-hand side of the arrow, we have one sodium atom and one chlorine atom. This equation is unbalanced because we have two chlorine atoms on the reactant side, but only one on the product side. In order to balance this chemical equation, we would need to add a number in front of the formula, which has the atom that we need to balance. This number is then going to be called a coefficient. The numbers can only be placed in front. We can't put it between the symbols, we can't put it at the end, because we know those subscripts that are to the bottom right-hand side of the atoms tell us how many atoms are present in the formula. For example, H2 is the formula for water, but if in an attempt to balance, we put a 2 beside the oxygen, we would have changed the formula, and once the formula has changed, this is now a new substance. This is now hydrogen peroxide. So when balancing equations, we can only put a number in front of the formula. By putting a 2 in front of sodium chloride on the product side, means that we now have two molecules of sodium chloride, and that 2 applies to both atoms in the formula. So we now have 2 sodium atoms and 2 chloride atoms. So chlorine is balanced. We have 2 chlorine atoms on the reactant side over on the left, and 2 on the product side over on the right hand side of the arrow. But we can see now that the sodium atoms are not balanced. To balance the number of sodium atoms, we simply put a 2 in front of Na. Now that we have equal numbers of sodium and chlorine on both sides of the reaction, we have a balanced equation. Now we saw displacement reactions before, where a more reactive halogen can displace a less reactive one from its solution. Here we have potassium iodide, and to that we're adding some bromine, and that will react to form potassium bromide and iodine. And this equation is unbalanced because on the reactant side we only have one iodine atom, but on the product side we have 2, and on the reactant side we have 2 bromine atoms, while on the product side we only have 1. Now, even though the number of atoms are the same on both sides of the reaction, so the number of iodine atoms must be equal on both sides, the number of bromine atoms must be equal on both sides. And to do this, we have to place a number in front of the formula which has any atom that we wish to balance. So let's tackle iodine first. Let's look at iodine. If on the product side we have 2 iodine atoms, then in front of Ki, I need to put a number that would ensure that the number of iodine would be 2 as well. So we're putting a 2. And that 2 goes for both atoms. So we now have 2 potassium and 2 iodine atoms on the reactant side. This equation is still not balanced because now we have 2 potassiums on the reactant side, but only 1 on the product side. So again, we need to put a number in front of KBr so that we can balance the number of potassiums. We put a 2, which of course goes for both atoms. So now on the product side, we have 2 atoms of potassium and 2 atoms of bromine. And since we have equal numbers of all atoms on either side of the arrow, then this equation is now balanced. For our final example, we want to tie in another concept, so let's practice how to write these formulas. We may not always have formulas stated in our questions. This example says sodium hydroxide reacts with copper sulfate to form copper hydroxide and sodium sulfate. So we would need to know our ions, and from our ions we can work out the formula of the compound. Sodium is in group 1, which means that its ion would have 1 positive charge, 1 electron would have been lost. Hydroxide is one of our complex ions or polyatomic ions, and it has the formula OH minus. So together they would form NaOH, sodium hydroxide. Next is copper sulfate, the copper ion Cu2 plus, sulfate ion SO4 2 minus. These charges would cancel and we end up with the formula CuSO4. These are our reactants, and it says that these would form, which means that the arrow comes next, and the products would be copper hydroxide. When we look at the copper and hydroxide ions, we see that we need 2 hydroxide ions to cancel those 2 positive charges. Remember to put your polyatomic ions in brackets if you have more than 1. And finally, we have sodium sulfate. And from these ions, we can see that we need 2 sodium ions to cancel those 2 negative charges of the sulfate ion. So now we have our equation. Let's balance it. When balancing equations that have polyatomic ions, check to see if the ions exist on both sides of the equation. So I have the hydroxide ion on the reactant and on the product side, so I'm going to keep it together as a group. Same for sulfate. I can identify the sulfate ion on both sides of the equation, so I'm going to keep that sulfate together as a group. So we have 1 sodium atom on our reactant side, but we have 2 on the product side. 1 hydroxide ion on the reactant side, 2 on the product side. 1 copper ion on the reactant side, 1 on the product, and 1 sulfate on the reactant side, 1 on the product side. So we need to balance our sodium, we need to balance our hydroxide. We need to place a number in front of sodium hydroxide that would ensure that the number of atoms of sodium and the hydroxide ions are the same on both sides. So we're putting a 2 in front. And that 2 goes for both the sodium and the hydroxide. So we now have 2 sodium and 2 hydroxide ions on both sides of the arrow. Since the number of atoms of all the elements on both sides of our arrow are equal, then this equation is now balanced. In summary, the law of conservation of matter states that matter can't be created nor destroyed, which means that we must balance our equations to ensure that the number of atoms that we start our reaction with are all there when the reaction ends. To balance equations, we put whole numbers in front of the formula which contains any atom that we wish to balance. tips, we can check to see if any complex ions are present on both sides of the arrow, and then we can keep it together as a group.